All right, so in this section, we're looking at equations of the form a cos theta plus b sin theta is equal to c. Example 49, we're asked to find the general solution. So this is asking for the general solution of sin theta plus cos theta is equal to 1. All right, one way I can approach this, and that is what the caption is suggesting, is that I should first write this in the form. If I'm starting with sine, I'm going to write this in the form, I'm going to first write sine theta plus cos theta in the form r sine theta minus alpha. So let's expand. I'm going to get r sine theta cos alpha minus r cos theta sine alpha. Equating coefficients, I'm going to get r cos alpha is equal to 1 and r sine alpha is equal to 1. Dividing r sine alpha by r cos alpha, I'm going to get tan alpha is equal to 1 divided by 1, which is 1. And so alpha is equal to tan inverse 1, which is 45 degrees. So I have alpha. Now that I have alpha, let's find r. I know that r squared cos squared alpha plus sine squared alpha would be equal to 1 square plus 1 square. So r squared, because cos squared plus sine squared is 1, would be equal to 1 plus 1, which is 2. So r is equal to root 2. So therefore, sine theta plus cos theta can be written as r, which is root 2, sine theta minus alpha, which is 45 degrees. So since it can be written like that, I can then therefore rewrite my equation as root 2 sine theta minus 45 degrees is equal to 1. If I divide both sides by root 2, I'm going to get sine theta minus 45 degrees is equal to 1 over root 2, which is the same as saying root 2 over 2. And remember, what we're asked to find is the general solution. So this means that theta minus 45 degrees is equal to sine inverse root 2 over 2. Now, sine inverse root 2 over 2 is actually 45 degrees. So the general solution is theta minus 45 degrees is equal to 180-degree n plus minus 1 to the n 45 degrees. All right. Then I could say theta is equal to 180 n plus minus 1 to the n 45 degrees plus 45 degrees. I guess if I wanted to, I could separate it into when n is odd and when n is even. I could separate it into when n is odd or when n is even. So, but let us not separate it and just say that the general solution is 180 degrees n plus minus 1 to the n 45 degrees plus 45 degrees. All right, so maybe we actually should have split this up into when n is odd and when n is even. So first, when n is even, I'm going to say when n is equal to, let us say, 2p, I'm going to get theta is equal to 180 times 2p. So n is even, so this is going to become plus 45 degrees plus 45 degrees. Because when n is even, minus 1 raised to an even power becomes positive. So theta would be equal to 360 p plus 90 degrees. Now, when, let's change the color again because the space is tight. When n is equal to 2p plus 1, that is when n is odd. We're going to get theta is equal to 180 times 2p plus 1. So since n is odd, minus 1 to the n is going to come out to be minus 1 times 45 degrees. So that's minus 45 degrees plus 45 degrees. So theta would be equal to 360 degrees p plus 180 degrees. Because minus 45 plus 45 is going to be 0, and p here is just, p is just an integer. P is just an integer. All right. So these are my answers. All right. So next we're going to look at example 50. Next, we're going to look at example 50. So example 50 is asking us to write f of x 7 cos x minus 24 sine x in the form r cos x plus alpha. All right, so let's expand. This becomes r cos x cos alpha minus r sine x sine alpha. Equating coefficients, we get r cos alpha is equal to 7 and r sine alpha is equal to 24. Dividing r sine alpha by r cos alpha, we're going to get tan alpha is equal to 24 over 7, and alpha is equal to tan inverse 24 over 7. So alpha is equal to this says alpha is equal to 73.7 degrees. That's alpha. Let's find out what is r. Here's what we know. We know that r squared sine squared alpha plus r squared cos squared alpha is equal to 24 squared plus 7 squared. So r squared would times 1 would be equal to 576 plus 49, which is equal to 625. R is equal to the square root of 625. So R is 25. And so f of x, which is 7 cos theta minus 24 sine x, 7 cos x minus 24 sine x is equal to 25 cos x plus alpha, which is 73.7 degrees. So this takes care of A. B is asking us to solve, hence solve. So we're at B now. B is asking us to solve seven cos x minus 24 sine x is equal to 4. So this becomes 25 cos x plus 73.7 degrees is equal to 4. Let's see if they give us a range of the answer. They want values of x between 0 and 360 degrees. So cos x plus 73.7 degrees is equal to 4 over 25. So x plus 73.7 degrees is equal to cos inverse 4 over 25. So the answers here in the first quadrant, it's 80.8 degrees. And in the fourth quadrant, it's 360 minus 80.8 degrees. So this becomes 80.8 comma 279.2 degrees. So that is what x plus 73.7 degrees is equal to. So now let's find out what x is equal to. X would be equal to 80.8 plus, sorry, not plus, minus 73.7 degrees, and it would be equal to 279.2 minus 73.7 degrees. X is equal to 7.1 degree, and X is equal to 205.5 degrees.